Record to the cloud. Great. Good morning, everybody. My name is Bob Conway, and I'm the organizer for Data Modeling Monday. And as the name implies, this is a weekly 1-hour forum where we talk about all topics data. So data modeling, data architecture, data governance, etc. This is about the 11th or 12th week we are into this group. The first few meetings we had, we talked about some of the mechanics of data modeling. You know, we talked about entity and attribute and relationship discovery and the type of metadata that we gather about them and maybe some pitfalls to keep track of. We talked about normalization one day. Last week we did kind of a pivot and we said, instead of talking about the mechanics of data modeling, let's talk about the process of data modeling, if you will. And I led a discussion about interviewing skills, kind of some do's and don'ts and so forth. A couple of weeks from now, a colleague of mine, Gary Rush, is going to talk about group facilitation, which is another way of gathering that. But sticking with that theme of the modeling process, I've asked Marco Wobben of Case Talk to lead the discussion today and talk about fact-oriented information modeling. So with that, I am going to turn it over to Marco. Let me make you the presenter, Marco, and I think I know how to do that. So more, make host, put in, yeah, I think I want to make you the host, don't I?
Co-host, yeah. Probably.
There it is. So Marco, you are now the host, and okay. I'm going to mute everybody else. I hope I don't mute you.
Test. So the question is, can it? Yeah, I see Bob nod because I can't hear Bob anymore.
Hello, everyone. Hey, Bob.
People coming in, I see, I hear. I am going to share my screen here and hope that that works.
Very good. And one question before you start, yes. Marco.
Yeah.
If people have questions along the way, do you want them to unmute themselves and jump in? Would you rather have them send you a chat or just hold them till the end?
It's all good. You can hold till the end, but you can interrupt me if you want.
Okay, so I'm going to mute everybody and turn it over to my friend here.
Fact-oriented modeling, not to be confused with the dimensional facts of a data warehouse. Let's put that clear. Today, I'm going to talk a little bit about fact-oriented modeling, as in how to do that using facts from the organization, from real data, start verbalizing those and come with an information model, and with the proper tools to be able to generate artifacts from an information model like that. This presentation is going to be in a couple of cycles, so let's get started with that. The opening slide, I'm guessing that the people from Europe might actually recognize this photo. From non-Europeans, probably not. However, we in the Netherlands have been fighting the water for a long time. That's probably well known, and you can hear that 100 times, but until you actually see the contraptions that we've built to keep the water out, it's probably very hard to grasp what that is really about. And this picture is one of the defenses against the North Sea. And I kind of like showing this picture because it's only been a couple of years that I've actually visited the place, and it is immense. And it illustrates how words or pictures can try to describe you something, but until you've been there, you know, really doesn't ring a bell. So similar to data models, where a diagram can mean a picture can mean 1,000 words, more than 1,000 words, and similar to this metaphor here. And we're going to talk about why we need something else than just drawing pictures. Let's see if I can proceed to the next slide. There it goes. Yes. So we're going to talk about the FCO-IM flavor of fact-oriented modeling, which stands for fully communication-oriented information modeling. And what we're trying to accomplish is that to get everybody involved in the data and in the information modeling efforts. And in many organizations, we see products, databases, all kinds of silos where data is. And at the same time, the more data comes to us, the more we feel the need to break free of those silos to be able to fuse all that together and make it work like one big organization. And then the challenge is, but what is really in those silos? So the who, what, where, when, and why questions come. And the only way to really answer that is to work with a method that answers all those. And once we have a data model or a good description, then how to move that forward, because as data grows, products grow, solutions grow, system integrations, it becomes a more important question that needs to be answered at the same time. And trying to make a little haste here. So having a model, having a description of your data then leads to the question, are you sure? Because nowadays everybody is affected by data, the decisions, the products, etc. And the question of, are you sure, is more pertinent than ever. And we have a couple of business cases for medical hospitals where they made an IT system to analyze which procedures needed to be taken care of in an intensive care department and which were obsolete, and all of that data, you really need to be sure that you have the right data and you have the right information models in place. And again, you can only do that by involving the experts that actually work on the actual intensive care departments. So in any way, data, it affects lives. And all of these perspectives built to the realization that even though in IT and in data management, we sometimes think that we are in charge of the data or the design or the product development, but we sometimes forget that this data is actually not ours. The data is from the domain experts that actually use and do the work. And therefore, I'm arguing that we should work with them so that their data is available to them and validated by them. And just doing IT, as some of you or may have been doing for a long time, might just always be the right approach. So one of the starting points is that we have data that moves from one place to another, and this data morphing, as you will, from websites to production to management reports, it's all about the same data. It always is the same meaning. It just shows in different shapes. And if we can maintain the communication between those different areas where data is manifesting, then we have something that is really valuable to the organization as a whole. And that would prevent cases where a product is built based on a premise by an engineer, based on an interpretation of the business, and would create a lost in translation aspect. What we're really trying to do is make the full circle, that if the business or the domain side of, or the business side of our world is communicating about data, then we need to be able to capture that communication. we need to be able to build an information model from that. We need to be able to generate, in most cases, a lot of technical design documents, or even the artifacts to implement systems, and bring that communication full circle, so that once we deliver an end product, it actually ties back to the original communication about data in the organization. So how to do that? A couple of cycles are always in place. We have John talking to Kate, and they exchange information, they exchange facts, they exchange data. And this is always a little bit informal. So one of the first stages is that we need to formalize that language. We need to standardize how do you, with your colleagues, exchange data in language. And once we have established that, we can then start modeling facts and then can bring that forward. And then the cycle starts again because we have a system and John and Kate are still communicating. In a large enterprise, this repeated cycle hopefully brings an environment where the language used between employees is starting to harmonize, and where everybody initially may speak their own native tongue, they start building a shared common language. So that's a little bit of a background, almost philosophical. So let's dig into the method a little deeper. We are not talking about modeling tables or entities and classes, nor are we columns and properties, etc. We're not going to model XML or JSON or SQL or RDF or any of the other flavors. What we're really interested in is the actual relationships themselves. Those are the building blocks. And this requires us to look different at data and information. So I hope this slide is readable to everybody. This is in a nutshell what the full cycle is about. In natural language, I write down a couple of fact statements, and these, and I will read one. The employee 465 performs a checkup for patient 123499 on 12/10/2019 at 2 o'clock. And these fact statements then are grouped, and they are reflecting how the organization communicates the checkup by an employee. By dissecting the information that is actually beholden in these fact expressions, we come with an information grammar on the bottom left. And I'm probably somewhat familiar with stuff that we did in elementary school. What is the subject? What is the verb? And all of those grammar-like structures that we've all learned in our native tongue. And then depicting it in some visual manner or artifact to talk to IT. But also being able to derive the same fact expressions from those technical artifacts so that the business can actually validate that we did okay or not. So let's start with a simple use case. Oh, I'll go back one slide. This is taken from the internet. This was a person that arrived at the office on Monday and said, my car smells a little weird, had to call car support of some sort, and they opened the hood, and what they found was the winter stash for a couple of squirrels that were working on a Saturday and Sunday, filling up the car. Just as a small anecdote. So what we're going through is, in this use case, is yeah, John calls Lisa because, you know, I have this car and I have car trouble, and what we're trying to do is, and this is a simplified example, so we've really tried to write down all the expressions, all the facts that involve the handling of data required for that step. So I typed it out in a computer and said, you know, driver John owns vehicle 22PZTV, and driver John requested a support ticket 8899. So I'm really making that concrete and readable for anybody who understands English in this case. And I'll write down the entire procedure. So somebody has a TV on somewhere, doesn't it? Or background. Anyway, I'll try to ignore that. Oh, wait, I am presenter. I can mute. Yes, thank you, Dave. So let's look at the first fact expression, driver vehicle. Driver John owns vehicle 22PZTV. And now on a type level, I can say driver owns vehicle. But you can also understand that writing it down in natural language with concrete examples is more valuable. And in the information grammar, I can dig into it because the driver is basically driver person. And the vehicle is vehicle license plate. When I build up this information grammar, and I'm doing that in reverse so that you can understand how the process works of getting natural language and then building the information grammar from it. This simple fact expression beholds a rich structure of information. And I can do that graphically, and there you will see that it shows you a ton of information. And it all starts with a simple driver vehicle, but it combines by placeholders 6 and 7, the driver and the vehicle. The vehicle then has a placeholder 8, which is fulfilled by a license plate. And under vehicle, if you can still read it with me, is an example that says 22PZ, etc. And on the driver side, and we're specifying the driver is actually a person, which makes driver the subtype of a person. And then the person in this case is identified by the person name. So you can see how a graphical representation of an information grammar, of a simple fact expression, becomes very rich in information. Let's go to the next sentence and start support request. Support request, driver John requested the support ticket 8899. I'm dissecting it in an information grammar on the left, and I'm visualizing it. Now notice that only the support request and the ticket number is added to the diagram. I am actually reusing the entire section of driver because I already put that in an information model. And I will continue. If somebody has questions, I will hear them, surely. The ticket vehicle, the ticket 8899 actually concerns support for the vehicle 22PZTV. And I just go through the process of structuring the information that is stated in these fact expressions. And by doing so, I can actually visualize that structure by adding more elements into the diagram. And in comparison to the previous one, the only new information building block is being added to this diagram is the ticket vehicle itself, because I already had vehicle and I already had a ticket. So now Lisa doesn't decide on her own, so she has to escalate this ticket. She's on the phone, takes in the ticket, and then reports it to whoever is responsible for that. So Lisa escalates ticket 8899. Now we introduce something called an employee. Again, an employee is also a person, so I introduce another subtype. And you can see that you can hopefully understand that by going through this type of information modeling, I'm doing two different things at the same time. I am able to communicate with our domain expert. I am able to communicate in the language of the domain expert. This domain expert doesn't have to know how I do it. And I don't make any interpretation on the domain knowledge either. I use what is given to me. there's a big distinction between this and most other modeling techniques, where in my head I have to do an interpretation of what's being told and I draw a diagram. In this case, there's a one-to-one relationship between how the domain expert communicates about their data and the information model itself. And the second part of that is, by analyzing these expressions, I have a means to communicate with the domain expert. So if statements are not very clear from the start, I have material to negotiate where we need to go from here. So I'll do a few slides further. There is an employee, Lisa reports to supervisor Ronald. So that's kind of cool. We again add a new subtype. And we keep adding fact expressions and their information grammar. And you may have also noticed that I was, like I said before, I'm not talking about tables. I'm not talking about objects or classes or attributes. I'm merely building the information grammar that is in these expressions. And then for the last part, there's actually an engineer that actually handles that ticket. So we ended up with an information grammar, which is highly detailed. And it's kind of like using Lego blocks. You can build anything with it. And by having these small little building blocks, we can then further on transform this information model into any artifact that we may need. And remember, this, for the people who see this for the first time, this relatively complicated information model came from just 7 expressions. From 7 expressions to an information model, but also from 7 expressions to a data model that can be verified. And I hope that this data modeling Monday, everybody will understand this kind of diagram. The only adjustment here is that at the bottom part of every table, it has 2 sections. One, it has a type level verbalization. Let's look, for instance, at the employee table. The fact expression number 5 says person name reports to supervisor employee person name. And then in the second part, it actually populates that with the examples that we gave in the information model, is Lisa reports to supervisor Ronald. So next to being able to understand the table, the columns, the foreign keys, the primary keys, etc., it also communicates how the domain users actually use that specific table and the data therein, which gives a far better ability to verify the data models. Now, of course, if you're a software developer, you're more interested in UML class diagrams, a slightly different model-to-model transformation, but also completely derivable from just 7 fact expressions. And then the generation of databases, one of the things that most system integrators and solution providers still do, build a database and make sure that it works and it is correct according to the business needs. You can see here the different tables all populated with the examples given by the domain itself. And on top of that, a couple of database views that not only represent the data that is stored there, but also add the communication that we started with in the first place. And I see a hand of Jed. Let's do unmute from Jed. Jed, you have a question or a remark?
I do, Marco. It's actually back a couple of slides where you had the facts
Okay.
and the statements underneath them.
Right.
And you said person reports to employee person.
Right.
I'm wondering if
That's,
there's a distinction, one more back, I think.
this one is the Lisa reports to supervisor Ronald.
Right, and then perhaps it
What?
was the next slide where you had the boxes and you had the 2 types of facts underneath. That said, persons reports to employee, supervisor, person. And I'm wondering if there's a distinction, whether it should have been employee person reports to employee person supervisor. And I don't know if there was a intentional distinction that was just person versus employee person.
Well, no, this is, well, I can say it's not relevant here, but that's because of the example. I could have just as easily said employee Lisa reports to supervisor Ronald or employee supervisor Ronald. It really doesn't matter in this case because there is a difference between the information grammar structure, which is basically all the connecting lines between, and I'm pointing to my screen, but you can't see that, is if you look at the top right balloon, it says employee and it drills down to person and drills down to person name and it drills down to Lisa. So that's structural information. And then you have what they call soft semantics, basically the cement between the building blocks that is printed in black. It says reports to or supervisor employee. So the reports to and the supervisor is soft semantics. It's the natural language bits that we as people use to make sentences, but it doesn't take anything away from the actual structure. So the interesting part is that even though I'm using just one expression for every building block, I can add a ton there. I can also say Lisa reports to someone else, or I could also say that there's an employee John who reports to employee Ronald. There are different ways of formulating it within the same information structure. So my deviation from Lisa reports to supervisor Ronald is easily fixed by saying employee Lisa reports to employee Ronald, because that will still fit the structure. It's just a different way of verbalizing. Does that make sense?
Good enough for now, thanks.
Okay, cool. Let's continue. Let's see where I was. We did that one, that one, that one, that one. Right. Okay, so we move on. So the interesting part is, and I will repeat in the end, these methods are a great tool to really understand the business and being able to communicate every stage of the modeling part, and to be able to verify if the information model being built is actually correct. And so how do we check that? Let's look at a different information model here. We have patient information on the bottom right. We have some employee information at the top right. We measure blood pressure on the top left. And then in the middle is a checkup with a specific date time. Now, you can imagine if you have an information model with a few thousand information elements, you'll want to be sure that it actually is correct. One, you do that by talking to the domain expert, but two, you may need to check on your own work as well. One of the things that we need to log while we're doing this and is to keep metadata. We're collecting all these expressions, but we're also wanting to be able to track down where they came from, who said it, which department. So metadata is part of an environment where we collect all these expressions. So let's not ignore that. Secondly, if we have tools to support this methodology, we may need to have automated checks. Are the business constraints modeled properly? Are there any modeling issues that we may need to look into? And there's a huge list of model validation rules. I'm not sure if Jed still has his hand up. One second.
Sorry, no, I don't, sorry.
Okay, cool. Okay, then I'll continue again. Let's go to my slide. So metadata to keep track of who said what, so I can go back and ask for clarifications, automated modeling validations on structure and all kinds of metadata, but also I can add verification on the actual examples being used. So instead of me on my own from my attic of garage or whatever, thinking about potentially rules, I will have to be able to talk to the domain expert on what are the actual business constraints that are in play here. And I'm taking one expression that says employee 465 performed a checkup for patient 123499 on 12/10/2019 at 2 o'clock. And you can see hopefully how I'm reading back the original expressions that I've stored in this information graph. So I'm going to move one slide forward, and I'm going to just simply use the examples given to represent back a set of questions. The first question is this a valid population for the fact type checkup employee, which states that employee 465 performs a checkup on patient 123499. But the second line says he also does a checkup on a different patient on a different time. Now, if the business would say no, that cannot happen, because we only allow employees to do one checkup on any patient ever. And I know it sounds a little ridiculous, but then again, we also state that two different employees cannot be present at the same checkup. And my burn rate on employees is extremely high, but it creates business constraints that follow and lead to a data model that has a patient checkup and an employee with an optional one-on-one relationship. Now, of course, it doesn't always say no, but sometimes it says, well, we still don't allow an employee to do more than one checkup, but we do allow multiple employees to be at the same checkup. So then I would have a different foreign key. And you will see that I don't have to think about how the foreign key is actually constructed. I can actually give examples to the domain expert who can then simply say yes or no. And these constraints will then flow through the data modeling generation part. Now, if my domain expert would say, yes, an employee can have multiple checkups for multiple patients, but no two employees can be at the same checkup, then the data model suddenly becomes very simple, because every patient checkup has a column for the employee. There's no many-to-many. And then we have the option where, anything is good. I can have an employee do multiple checkups, but I can have multiple employees at the same checkup, so I generate a many-to-many relationship. So this kind of model, this kind of validation by the domain expert will actually drive the data model forward. So let's see how we come from information to an implementation. First of all, I'll show you briefly the matrix of where in the area of data models we are actually modeling our parts. And we're doing this with the business requirements in what we call a conceptual area with an meta information model. And with the tools and methods and mathematical algorithms, we can then group your information model, we can reduce the information model, we can lexicalize the information model, et cetera, to come to UML class diagrams, entity relationship diagrams, logical, physical, all of that can be derived from such an elementary information model. And once we've done that, you will see that an information grammar, the diagram that I showed earlier, where the checkup is actually modeled as an information element, it then may become a checkup table in my DDL statements. It can also be a checkup entity in my XML schema. There's no loss of information, and I can drive the communication and the examples forward. as you can see here, for those who read SQL, I create a couple of domain names, then I declare my patient table, neatly commented for the DBA to read how the end user will actually use that table. And for the software developers, very nice, insert my example population. And to make sure that we bring back the communication from the domain expert back to the domain expert, we also add a couple of database views that basically state, we have a select on the base table where the data is stored. We add some concatenated text to it with all kinds of data elements in there. And then if we query the base table and the expression view, we see the data in our production database, but we also add to that how it's being verbalized by the domain users. And this brings us sort of all the way back to the domain expert that can actually use this in their applications being built. They can do the data entry part, and they can also have this little text field in the form that specifies how the data is being verbalized. And we've seen this before, couple of tables, again, with type level expressions, with real data expressed in there, so that actually the logical diagrams can be validated as well. UML class diagrams shown that high level concept maps. If you have a very detailed information grammar, then sometimes it's not very convenient to communicate precisely that, and you want to have a high level map generation of RDF-AL graph information. And I'm just going to show you a few different outputs. The people that are involved in all kinds of web services or messaging software, JSON schema, no problem. And then very interesting, big organizations usually have an invested set of tools like ER Studio or Power Designer. The tools that support this method actually have a couple of transformers that basically generate a VB script that can be run inside of ER Studio or inside of Power Designer, and it will just on the fly create your conceptual, physical, logical, or relational model, depending on what you're looking at.
Hey, Marco, could I jump in with a question?
Yes, yes.
Bob Conway. You showed earlier, maybe 5 or 6 slides back, and you don't need to go back,
Yes.
but you
Okay.
showed an example where one of these English sentences generated an artifact of, like, I think it was whether or not one employee could check on multiple patients at the same time, or if multiple.
Right, right. Yeah.
And you resolved that by asking an explicit question. And the business user came back presumably and said, no, only one employee can check a patient at a time. And when you did that, you illustrated how your diagrammatic representation of that data sort of collapsed and simplified itself by removing that ambiguity. I got that. My question is, you're showing us now how you can take this diagrammatic representation of the English language and reduce it and render it into more structured information like DDL and ERDs and so forth.
Yes.
I guess it's a 2-part question. First of all, I know that you have a software tool behind this that does all that. And so my first question is, when I go back to that base knowledge set and make those corrections, do those corrections flow forward, and do they get rendered in all of these subsequent reductions of the data? In other words, does it go fix the DDL of the database and so forth? Or how mechanized is that process, I guess, is my question.
That's both parts of your question, I presume. it is we're only okay. So there's a couple of things to say to that. From the methodology, it's all about gathering the business requirements, getting the natural language, getting the examples, getting the constraints, all that. So the tool that you refer to is basically providing functionality to do all that. And then there is a zillion amount of artifacts out there in IT landscape, which is a database. But even in databases, you have another zillion flavors and brands, etc. So what the tool focuses on is the capturing the richness of the information model, generating the almost, if you will, the greenfield artifacts, and then trying to hand that one over to specified specialized tools for those artifact domains. So for instance, ER Studio has great capacity to do all kinds of delta processing and differences between models, etc. So instead of reconciling all the changes within our information modeling tool, we basically offer a new version of the information model to, for instance, ER Studio, who can then do the delta resolvement very well itself. So
okay, that's a good enough answer for now. So I did have a second part to the question, but I'm going to hold it until the end. Let me let you keep going.
Okay. I mean, there's more to say to this topic, but we try to basically hand it over as best as we can and as well documented as we can, so that the different technical domains can then pick up and continue their developments. So I'll give you two more examples, because this is Monday mornings are short. I'll go through that briefly. One of them is a customer. The concept customer comes back to haunt us in this field. And if you talk to the business, then everybody might have a different definition of what their customer is. So what I instead suggest is that to not focus too much on a customer as an entity, but look at the data that's being registered. And you may find different domains that have different information and different identifications for these customers. And by simply using these statements and modeling it, you will discover that there is a generalized structure for customer that has different roles in different domains. And Bob is recording this, so you can look it back and press pause while I continue with this. Another example would be, we have regulations in the companies, and these have all kinds of different exceptions, calculations. And for the example of our employee who has 22 vacation days, this may be a European example, I'm not quite sure. We can also say that everybody who's younger than, etc., etc. So let's work with this. Let's do fact-oriented modeling on a piece of text like this. First of all, let's write down all the different conditions. So the age is important, the employment years are important, and then the outcome. By simplifying this and combining all the common cells, we end up with only a few outcomes and a few conditions that are actually relevant. Now, the interesting part is we can now verbalize real examples on what those cells mean. So for the standard vacation days, employees receive 22 vacation days. And even on the bottom right, it says employees with an age from 60 to 99 years receive 3 extra vacation days. We collect all that. We also combine a couple of HR examples that employee John is hired on 1st of January 2011. And we combine these two. On the left, we have the real examples of employees. On the right, we have the verbalizations of our regulations. And we simply built an information grammar for this. On the center part, it says vacation days, identified by the amount of days. And on the left, you will see the employee that has an employee vacation days, which is a derivable construct, which uses everything on the right as input for the calculation. Driving that forward again to a data model, I will have this employee table on the top left with my example data for the employee, and all the other tables are my configuration data, so you will, according to the regulations. And you can see that every fact expression that is being displayed there represents my regulation. And for software developers, of course, I can generate my UML class diagram that services that piece of software. Excuse me. So let's do the summary, because we still have 12 minutes and people might still have a few questions at the end. This methodology is documented in a different set of books. It is extremely well equipped for data models that need to be of an extremely high quality. Think medical hospitals, think airline companies, think railway organizations, think banks that may have a huge amount of types in their organization, where a specific domain might be very complicated, that you really need to get involved with the domain experts, or where governance is very important, where you need to track down every statement that is being made and being added to this information model / data model / artifact pipeline. And in the background, you see here depicted one of the many information models that were built, which has over 3,000 information elements in there, leading to a database that has about 300 tables, but every statement in there has been checked, populated, and stamped and appropriate signature. Just a little demo wheel. With this methodology, it touches on metadata, data architecture, and data modeling and design. And as Bob mentioned, there is software for it, because without that, it would be a lot of manual work. So I have added a few screenshots of the software. We have a modeling environment, different diagrams to show it to different professions in the IT domain, version management, difference reports, all of that is available. And for governance, we also added a portal to be able to track every statements throughout the enterprise. So with an, yes, 9 minutes on the clock.
Go ahead. This is very closely related to the object role model, an IM model. Can you tell me the difference?
Yes, I can. There are different. Okay, so good question. Let's see if I can pull myself back into the screen here. Stop sharing. See, there you go. Dave. Okay, going back in history, it all started somewhere in the 70s, where binary relationships and semantics were combined shortly after that. And this is history lesson number 1. And this was mainly done in the Netherlands at the time. Research was done in non-binary relationships and semantics, and it continued to NIAM, who's still active. And who had at the time a student who was Terry Halpin, who developed object role modeling. And in the 90s in the Netherlands, FCO-IM was further developed. And they all have a slightly different emphasis on information modeling. Object role modeling is focused on a rich environment for business constraints, and takes the tooling that they have from the point of view of a drawing an information model. It really is like many logical modeling tools. you drop an element in there and you give it a name, and then you add attributes to it, you add relationships to it, and you do that by drawing it. So it emphasizes on the constraint and does it starts as a drawing tool. The FCO-IM part takes a different path because it tries to really emphasize on the communication of the domain expert and tries to capture the rich information grammar underneath that language. And the tooling then, of course, it has some refactoring capability, etc. But the method in itself focuses on that communication. So there's a clear distinction between drawing an information model versus actually analyzing the language that's being used by the domain expert. So there's a strong difference there. And then you have different flavors still. I mean, in Australia, there's some development going on. And we've seen in the past, and it's still being used, the SBVR for verbs and concepts, etc.
Mm-hmm.
I hope that is a...
Good, very good. Thank you.
Yeah, okay, you're welcome. I see some chats coming up.
I had a follow-on question, but let me give other people a chance to ask before they...
Yes, my day is not almost over, so I have plenty of time now.
Okay. And we can run past the hour if we need to. So by all means, if you have questions, jump in.
Cool. I see that Sander Robijn says something, but he's dropped off the radar already. Yes, Bob only gave me an hour in principle, so I had to really condense it to a few short examples. But I can talk about this for days, of course. You can imagine.
No, I appreciate you doing a good job. Let me ask my second question, and that is this. Whenever I've done data modeling, especially when I'm talking to non-data people, I always start out by saying the two biggest obstacles we have to communicating is number one, the English language and all of its artifacts, and number two, the organization chart and all the constraints that imposes on us. So those are our biggest enemies to data modelers. And the problem is that it's nothing specific about the English language. I'm sure it's true in Dutch or German or Arabic. There's multiple ways to say the same thing, and something stated can mean multiple things. That's some of the inherent ambiguity in communication.
Yes.
We're trying to resolve by putting together a more algorithmic data model. And I could have said A supervises B, or B is managed by A, and those mean the same thing, but only if you speak the language. It's hard to resolve those things, ambiguity. So I guess my point is that I see this of value of being able to take spoken or written language and parse it into rules, but I also see it as fraught, as introducing lots of potential ambiguities and redundancies and maybe even conflicting information in the model. So can you speak to that, of how we can match these things and somehow tell the tool that Marco managing Bob means the same thing as Bob reporting to Marco? So however it was stated, recognize those are the same and merge them, if you will. Do you have that kind of ambiguity resolving features as part of the tool set? Can I build rules for those kinds of things?
Well, it's actually, so this is okay. This is an interesting problem in many technological driven methods or tools. But as soon as you see that we're really trying to focus on the communication parts, and I haven't shown you in the examples, I must admit, and because I cut out a few slides, and I'm coming from the Netherlands. We're a very small country in regards to what we see out in the world. So we're very accustomed to use to at least speak to one or two different foreign languages at the same time. And the interesting part is that both statements that you made on Marco or Bob reports to Marco, or the other way around, different ways of stating the same thing, is basically I'm using different what we call soft semantics, but it has the same information grammar in there. And you and I are speaking English. The examples were in English, but they're in theory and in tool, there's no problem of adding French and German and Dutch to the same information model. Because I'm entering the expressions and I can specify this is done in Dutch, this is done in English, this is done in German. And they add to the same information grammar and the same structure. Because it really tries to focus on the communication part. It actually supports communication in itself.
Yeah, my question was that even within a given language,
yes,
just pick
sure.
English because we all speak English on this call. Even within that language, there's the ambiguity that there are multiple verbal ways to say the same thing.
Right.
And also that having said something, it can mean multiple things.
Yes, yes, yeah.
So it's that many between semantics and syntax, if you will. And that was my question, is if you're parsing any language and putting these structures together, there's exposure and opportunity not only for ambiguity, but even to potentially create rules that conflict with one another.
Sure.
Because
sure.
It's the ambiguity of the communication method. So,
well, that's I mean, the first time I show it to people, there is always the impression that it is automatically parsed by some sort of black box or whatever. But I assure you that every step that you have in the information grammar is done by hand, by approval of the modeler. So by steering that process and nearly supporting it from a tool point of view, the disambiguity is done by talking about it, talking to the domain expert, because me as a modeler, I have to understand the domain and I have to learn how to speak the language of that domain, not the other way around. So until it's clear to me, I'm not doing my job right. So then the part of what we call synonyms, customer, in some departments it's called a lead, in some departments it's called a client, but those are synonyms for the same data, so you will. Although the same data, it may have the same identification, but it might not actually be the same data. But there is room for synonyms. There are different ways of adding those alternative names to it. And then we have the part of what we call the homonyms. I speak too much English and I sometimes forget my Dutch and sometimes I'm mingling up words, but there can be a word in it that has two distinct meanings, but you spell it the same. And for that kind of support, there's always this, if you can annotate in which context this word is to be read, then you have solved that ambiguity problem with homonyms, and tools support this kind of methodology without any problems either. And it doesn't take anything away from the natural language in itself. And I think that's one of the key distinctions between all the other technical tools, is then if you're doing that in a physical database, you will have to come up with a prefix or a schema name or whatever. You have to make that visual in your diagramming tool. But once you understand the methodology and you realize that there is a tool that supports homonyms, synonyms, etc., you will also realize that it's not really that much of an issue anymore. Because I can say, I have a customer, but it's not the same thing as customer A. There is a distinction between those two words, and the one is for the help desk, which is an entirely different customer than for the sales customers. And once you can add that distinction in your information model, you have solved that dilemma.
Other questions for Marco before I have 1 minute after 10 a.m. here in Denver. So any other questions before we stop the recording? Okay. I want to thank Marco. I appreciate it. And just a little preview of the next couple of meetings. Next week, I'm going to ask Jed. He's going to talk about an entity lifecycle and looking at data entities as not just passive objects, but things that interact with business processes and how their states and status and change and so forth. So that should be an interesting discussion. The following week, Gary Rush is going to talk about group facilitation techniques. Gary's sort of the master of that. I learned from Gary some 35 years ago. And the following week, I'm actually going to combine this session, Monday morning, data modeling, with a bi-monthly meeting I do on data lakes and integration. And Bill Inman's going to be talking about the merging of unstructured data, text, for example, with relational data, which may dovetail well with what we learned from Marco today. So that's kind of a preview for the next 3 weeks. And I don't have a schedule beyond that. So anyway, there will be announcements going out for those. Again, this time I want to thank Marco, and I'm going to go ahead and stop this recording, and it'll get posted later today. Okay. All righty. Thank you, everybody, and have a good Monday.
Thank you. Have a good one.
Okay. And thanks again, Marco. And I'm going to close out the meeting now. Bye-bye.
Yeah, thanks. Well, we're still here. Did you have a reference text? I know you showed a text. I'm sorry. Is there like an open source software, or is this your product you're selling, or?
It is a product that is available on the internet. If you go to kstock.com, you will find everything there. It comes in a few editions. There's an edition that accompanies the books that are out there for free. It has an educational edition for schools and universities, personal, professional, enterprise.
Okay.
So
There'll be a chance to try it out and use it a little bit, and be familiar with it just as with the book.
No problem.
All right.
If you have any questions, just reach out to me, and I'll be happy to support you wherever I can. And
I appreciate it.
Yeah, no problem.
Have a good
Just
day.
cool.
Yep.
Good.